this course, again there's a problem. Display settings. So this is a course in object-oriented programming, CSC 404. It's a core course in your BTech course, and put it here. So this is an introductory class, and where I plan to talk about the basic differences between. So as the name goes, it's object-oriented programming, and all of you have done a course in C language. So what kind of programming paradigm that was? C language? Any idea?
Structured. So structured.
The functional.
Procedural.
Functional.
Yes. One says structured, and what other answers are there?
Procedural.
Procedural. Anything else you would like to mention? Any other terminology?
Sir, functional programming.
Functional programming. And what else? Okay, so this C programming, it's basically it's almost a structured programming language. Now, what is structured programming language? I'll try to give a basic idea about that. But you can still write unstructured codes in C. That is possible, and it's a procedure-oriented programming. So that is what we would like to highlight here. And before we get into this course, which is primarily an object-oriented programming language, so the previous one was structured, it was procedure-oriented, and now it is object-oriented. So this is not only just a change in syntax or a change in some features, but it is probably a change in the entire philosophy of the design. The design philosophy completely changes. When you are given with a problem, and if you are using a procedure-oriented programming, C-style programming, so the design that you will have, design means the way you define the data structures, then the functions and how you organize them and all this. So the entire design gets changed. Okay. So we'll see that why that change is required. I mean, what is the limitation of that previous approach, and why we need to change it completely, and what is the language that supports this. And I mean, it's known to all of you that object-oriented programming, there are a number of languages that supports it, like Java, C++, and many other languages, and the Python and all this. So in this particular course, I'll be using C++ as a mode of programming. But again, the concepts of object-oriented programming, or the features of this, and the overall advantages that we discuss here is still valid in other language domains also that supports object-oriented programming. So that's a basic idea. So, and what I generally do, I start with I mean, when I start writing the codes, I start with a C code, a very simple C code, and then I try to okay, is the recording on? Can you check?
Yes, sir, it is.
Yes, sir.
Okay, so I'll try to rewrite that same code in C++. So the idea will be just to try with the temperature conversion, Fahrenheit to centigrade. That's probably the very easy to write code. So we'll write the C code of that, and I try to rewrite it in C++ and see the differences. And from there on, we can figure out that how stepwise the changes are revealed. So and then from there onwards, we have one advantage here, because I took the some classes on pointers. So pointers are still relevant in C++, and we have already done it in C. So we'll have almost we'll summarize in one class the entire concepts of pointers. But one new thing that will be introduced here is reference, and that is available. What is a reference type variable? Why it is useful and all this. And then dynamic allocation, we used malloc, calloc, and free. So here we'll be using some different some other we call it operators like new, delete, and all this. So dynamic allocation, the same concepts will be there, but it will be done in a different way. The syntax and the actual techniques will be different. So those things we'll do, and then we'll gradually discuss on the basic features of object-oriented uh, technology of object-oriented programming. So that's the idea. And so before I start with this, so how many of you know C++? Some are waiting in the lobby. So how many of you are have used C++ as a language?
Sir, we raised our hand.
Hello? Yeah, I cannot see the faces, but
Yes, sir.
Sir, we
yeah.
raised our hands, so you can see there.
How many of you have written codes or solved problems, have done some projects in C++?
We have
Can you
raised
just
Sir,
hands,
in
sir.
sir, in MS Teams, we have raised hands. Those who have code written code in C++.
okay? The main problem is I cannot switch back to that. Okay, so I think many of you have done that, and I think and how many of you know Java?
Yes, sir.
Is it
No.
is it so? Which is having a larger fraction, C++ or Java?
So
C++.
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 C plus plus, sir.
C++
That's
45
good.
around, sir. Java is
So it's always good to have some prior exposure in C++, but it's also not to have any exposure, because sometimes you take it too easy, but or maybe some concepts may not be properly clear to you, but even though you can write codes. So I would suggest that those who do not know, uh, they are also having a big of advantage, because they will learn from the scratch and without having some bias to whatever they have learned till date. But those who are already knowing it, they also have the advantage that they can tune their understanding, or they can have questions that uh, might be interesting to discuss, like any kind of debates you can have. So it's good for the whole batch. Okay, so these are the so this is the outline, as I mentioned. So it will be so initially we'll start with uh, the topics or the understanding of what we all know. So that is procedure-oriented programming. So we'll figure out the features and limitations of that, and then the real world perception of how we view the real world and all this, and then we gradually come to the object-oriented paradigm and its terminologies, features, and then we write the first C code. So that is a outline uh, of our introductory classes. It may take one or two lectures to complete this part. Okay, so if we take the these are all scribed, because these are the uh, PPT saved from the previous year's lecture. So if I focus on this, so if we take a very simple problem of result processing to create rank list and finding attendance defaulters. Okay, so for a particular batch, and if I would like to write it in C, so what do I do? So how I do that? Result processing to create a rank list and finding attendance defaulters. So what I need to save here, what I need to store here is the marks obtained. So
And attendance.
I need to store here the marks obtained by the students, and that I can do in using a one-dimensional array. Okay, and you can have, say, because to process the attendance defaulters, so I have got different lectures, so maybe I have got 20 lectures, so lecture 1, lecture 2, like that. So I've got another 2D array which stores the information of whether you attended that class or not, and maybe say I'm having 180 students, so like that. So these are all trivial, so I will have a 2D array and a 1D array to store the values, and then to solve this problem in C I will have a main function. But if I would like to do the solve the entire problem here, uh, so in that case it will be uh, maybe a pretty lengthy code, so I may divide into submodules or functions, right? And generally what we do, if the main is too big, in this case one simple function can be reading of the marks. I have to read the marks which the user need to input, and then I have to create a rank. uh, so so this read marks, after reading the marks, I'll call maybe the create rank procedure, and the create rank will actually call some sorting techniques to sort it. So that can be another function call. Okay, and then once we have done that, then I'll have to read the attendance in this 2D array, and then I have to find out the defaulters. Defaulter means if I'll find out how many zeros you have got, that means you have not attended, and if it is below the threshold, I say that you are the defaulter and your marks cannot be published, like that. And finally I'll have a display rank uh, procedure which will display the entire results, right? Just a minute. Okay, so in this case what we mainly see, I mean, uh, as you can see here that these are the data structures. So what are the how many data structures we have used here in this particular problem, as we have discussed it? How many data structures we have used?
Two.
Hello?
Two.
1D
So
array and 2D
1D and
array.
2D array.
Yeah, so there are two data structures, and how many methods or say functions or procedures we have used? Say 1, 2, 3, 4, 5, 6, and including main there are 7 total maybe. Now the thing is, these set of functions are operating on which particular array?
1D array.
This 1D array. And these particular set of functions are working on which particular array? This 2D array, right?
Yes, sir.
But when you write a C code, if you think of the physical contents of that code that you wrote, so you'll have this array declaration, and it's a bunch of 6 or 7 functions. So all are in a it's a set of data structures and functions. Now, do you have any kind of mechanism to relate these 3 functions with this particular array and these 2 functions with this particular 2D array? Is there any mechanism in C to relate uh, the data structures and its related functions together, to combine them together and to keep them in one place, or to bind them together? Is it possible in C?
No, sir.
So you can keep it in a separate file.
No, I mean, keeping it in a separate file, that's a different thing. But if I would like to have it in the same file, yeah, that is possible. You can keep it in a header file and all this. But if I would like to have it in the same file, can we uh, combine them together in some logical form?
No, sir.
No,
In
sir,
a
because
class.
they will take different arguments.
No, I'm talking about very simple things. These three functions is related to only to this 1D array. So I would like to have them together somewhere
So we
together.
can do
Can I do
structures.
that?
So we can
Yeah,
use
if I define
structure.
a structure in C, structure what it can do, it can combine several data structures, right? In a C structure, in a typical C structure, it can combine, you can write that this is a structure, and you can write this is a 1D array, say A is a 1D array, okay? Then there can be another 1D array B, there can be another float variable F, and all this. But can you, so in your structure, can you put here functions also, related functions
No,
which
sir.
operate in these data structures
No,
in C?
sir. No,
Are you
sir.
In
getting my
C, we
point?
cannot.
Are you getting my point, what I mean to say?
Yes,
Yes,
sir.
sir.
So the C structures are limited to combining or putting together okay. Okay, so in C the basic problem is you can put only you can put together the related data structures or variables, but you cannot combine within that construct related functions, right?
Yes, sir.
And that is what you expect, because that is logically also meaningful, so that you know that this is a unit. So although they are having a lot of cohesion, but you cannot put them together because that is a restriction. So there are many such things that typical C, or you can say that a procedure oriented language is having. So why it is so? Because in C it's a procedure oriented language, and you basically focus on procedures. Procedure means, so these are the procedures, 7 procedures are there, or functions. So the basic emphasis is in identifying and writing those procedures, and not trying to go beyond that in putting those procedures together with the related data structures and all this. So that's a basic, that's one of the limitations that any procedure oriented language suffers from. Okay. And here whenever you are writing a C code, you just say that okay, main is too big, so I'll have say two more functions, and that function is too big, then I'll divide into few more. So you start looking from the main, and you try to probably divide it into sub functions or sub procedures, and then keep on doing that like that. So basically the approach of design is more of top down, right? Start from main and then keep on doing that. And somebody of you may have done the entire sorting in the create rank itself instead of calling a sort function. So basically always keep your focus on functions, identifying functions, and that too trying to identify the functions in a top down fashion, right? So do you agree on that?
Yes, sir.
Yes, sir.
Yes, sir.
So that, so try to now understand what is the, I mean, design approach, and where lies your, where you might like to have some changes, right? So these are the basic features of any procedure oriented design paradigm, and C is just a language that supports that. So it's basically takes a top down approach. Its task is to identify procedures which are in different terminology you can call it as subroutines, modules, or functions, and the procedural properties. And when you have identified, say you have identified, say the create rank or sort, some function like this, so your basic subtask is your basic goal is to encode it, write the logic for that. I mean, you just write the function, that's all. So when you write the function, you basically implement the module using a structured code. Okay. So now another term comes, that is called structured code. So can any of you specify what is structured code or structured programming? I think some of you mentioned the term. So do you know what structured code means? Hello? You can speak in your own terms. I have written something here. It's already there in the slides. But do you know what structured coding means?
So it
Hello?
will use the C structures actually. It
Hmm?
will use the inbuilt structures. So it will use
No,
the
no, no.
inbuilt
It's
structures.
not. It's not related to. It's not related to this structure. So this is not. This is not related to this structure. So this is not that. If you have understood that, it is completely wrong. So structured coding means something like this. So if you write a for loop, in C plus, I mean in C, you know that there can be nesting, right? You have used nested for loops or nested loops,
Yes,
a
sir.
for loop within a
Yes,
while
sir.
loop
Yes, sir.
within that. So you can have any level of nesting. Nesting means this for loop, this outer for loop, so I mean this inner for loop is completely inside the outer for loop, and you may have another for loop completely inside the inner for loop, like that. So nesting means like that, right? You completely nest it. But can you have something like this? Can you see this? Can you have something like this? A for loop starts. So here it starts, here it ends, and you start a for loop here and you end in another for loop here. Is that possible in C?
No, sir.
No, sir.
No, sir. No, sir. No, sir. No,
Can
sir.
you visualize this thing? I mean, I'm not writing a code, but can you visualize? Can I ever start, forget about a for loop, can I start any loop in between and end that spans beyond the one from where it has started?
No, sir.
No.
So this is not possible. And such things are basically called unstructuring. I mean, this is an example of unstructured code. So this is what called, so this, if this happens, if such, so loops are nothing but repetitions. So you say that I'll repeat these steps, say step 4, 5, 6, or these few lines repeatedly. So how you say that? That there are different ways. We can use a do while loop, a while loop, or for loop. There can be many other ways. So if you are able to do that using some syntax, and if you end up with such things, then you end up with writing unstructured codes, and that is not recommended. But if you can do it like this, you say it's a structured code. Is the difference between structuring a structured and unstructured code clear?
Sir, please repeat this part once again.
So is this part clear? Nesting?
Yes, sir. Nesting is clear.
Yeah. So using for loop, do while loop, or while loop, can you ever have such kind of codes, which this type of structures?
No,
That a
sir.
loop starts here and the loop ends here. Another loop starts here in between but ends here. Is it possible?
No, sir. It's not possible.
This is not generally possible, and in fact all the modern programming languages, they are not provided with any such features which through which you can write such things. But have you ever used go to level in C? Go to statements are
Yes, sir.
available in C, right? Go to statements, have you ever
Yes,
used?
sir.
Go to
Yes, sir.
L1. So L1 is a level. So this level can be A, B, C, whatever, colon. So go to means, so you see, if I write here L1 colon and I write something, then I write the condition statement here. If the condition is not, if the condition is not true, then go to L. So that means it basically comes back here and keeps on doing something. So using go to, can I write a repetitive block in C?
Yes,
Yes,
sir.
sir.
And if I use two go tos in such a way that this is corresponding to this loop. So okay, this L1 and this go to L1 corresponds to one loop. I mean, you can use implement a loop, right? Using this, I mean, a repetitive block. And here you start another L2, and here is the go to statement. So can you see that it ends up, you basically end up with an unstructured code.
Yes, sir.
Can you see this? So go to those who have not tried it, you can immediately after the class you can try something like this and it will work. I mean, the compiler will not trigger any warnings or maybe any kind of errors, but you are trying to come up with something that will be difficult to manage later on, and it is not recommended from the software engineering perspective. Are you getting me what I mean?
Yes,
Yes,
sir.
sir.
So this becomes difficult to debug later on if you have got lots of unstructured codes in your entire program. So it becomes very difficult to debug, and for that the standard loops or this for loop, while loop, do while loop, you cannot really have this kind of structures. But it's just to mention that implement the module using a structured code. So I think you got the idea what structured code means and why you should only stick to that, because of debugging problems or because of finding out fixing bugs later on. Is that fine? So what it means, no overlapping of loops, no jump directly into a loop using goTo's levels. So you may not be able to jump directly to that loop. Is that part clear?
Yes, sir.
So what I mean to say is procedure-oriented languages, like when you write using C, so these are the general features. You identify the procedures and you implement them using structured code. And there are, when you identify the procedure, so these are the two things that you should keep in mind. Can you see this? It's so the each procedure should be highly cohesive. Cohesive means they should consist of only related set of instructions put together. So when you are trying to do a matrix multiplication, probably you not it's not recommended that you also include the reading of the elements in a 2D array as a part of it. Okay, so it's up to you how you say that what is actually related, what is not. But if you write a matrix mult as a function, probably you should not write the displaying of the outcome as well as reading the input to the array as a part of it. It should be purely just multiplication. It's only that part. Okay, and low coupling means uh, low interaction and dependency with others. That means if I write say 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 4 functions in my program, but if I find that the functions are too much dependent on each other, so when f1 calls f2, so f1 has to pass a list of say 20 arguments. Okay, only then it can call f2, and f2 when it calls f3 it has to pass a 40 arguments, only then it can call f3. What does it mean? So their coupling is very high. Coupling means they are dependent on, so the thing is they are not independent. So to get f2 called, f1 has to pass so many arguments, only then f2 can be called. Are you getting my point?
Yes, sir.
Yes, sir.
So you'd probably like to have something that a function calls another function without passing any arguments. That's the ideal situation. Sorry, ideal situation. So that's a base situation, but that probably may not occur always. So you probably have to pass arguments, but your design should be such that the number of arguments that a function passes while calling another function should be as minimum as possible. And that is not always very easy. I mean, it depends on the design, it depends on the problem, it depends on your skill also, and it depends on how you define the data structures and all this. So a simple thing can be, if you make everything global, do you need to pass anything?
No, sir.
If you make everything global and a function is calling another function, probably you don't have to pass anything to that particular called function, right? Are you getting my point?
Yes, sir.
Yes,
But
sir.
if you but hello, yes, any question? But if a function keeps everything as local, then what happens? F1 is having everything as local. So then when F1 calls F2 and wants to do something out of it, so it has to pass all those, maybe the entire array you have to pass, or the base address you have to pass, we have to pass everything. So then you say that, what do I do? So you have to organize the data in such a way that your procedures are low in coupling and they are highly cohesive. So if you put in the previous example, if you put everything in the main, that means it is not a very cohesive code. You end up with just a single program with a single function, but it includes almost everything inside. So it becomes again difficult to debug and all this, and it becomes difficult to read also. And above all, it becomes difficult to reuse the code. So if I would like to reuse only the sort, or if I have somewhere implemented the sorting function, uh, I can just reuse it here. I can call that function. So the code reusability becomes uh, I mean, it becomes it's not easy if I don't go for cohesive, highly cohesive functions. Okay, and when you make them highly cohesive, you have to keep in mind that they should be low in coupling also. So are these terms clear to you? Cohesion, coupling, structured code, and top-down approach?
Yes, sir.
Yes, sir.
So these are the things, maybe in subconscious you are having it when you are writing a C++ code, but these are the things you should follow to have a better code, better readable code, better manageable code, because sometimes your codes you wrote and maybe somebody else will be taking care of it several years back. Several years after you have left your job. So those are the things, and apart from documentations and all this. Now the thing is, in the procedure-oriented design, what are the limitations that we can identify out of it? So the inherent cohesion between data and procedures cannot be captured, right? So the one that I pointed out in the very first slide, right? So we cannot probably have some mechanism in C where I can put together these three functions along with this 1D array. So that is not possible. So the inherent cohesion between data and procedures cannot be captured in this design. In C, it is not possible. C structure means it is purely, it can put together data structures, variables, and that's all, but it cannot include within its definition. So I cannot think of something like this struct and that 1D array which stores the marks, integer or float, whatever, along with what are the functions there? Read marks, create mark, read marks, create rank, and sort. So it is read marks, create rank, and sort. So now there is the inherent cohesion between this and this, right? But if it is a C, pure C type structure, this is not possible. Is that fine? Now you might argue that, okay, in my C compiler this works. So these are not pure C compilers, they are more or less C++ compatible. So if it is a pure C structure, this is not possible. In fact, it is not meant for that also. So you just focus on procedures, that's all. Is that part clear?
Yes, sir.
In C structure is not, but if it is a C++ structure, the same struct keyword can be used. So if it is in C++, this is allowed. Is that part clear?
Yes, sir.
And another is not totally reusable. So earlier, what you in C, what kind of reuse was possible? So I wrote a sort function. I can reuse it in many of my other say applications or other assignments. But say the entire stack. So stack means what? So if I say stack, so what does it mean? The array that stores the elements of the stack, the push, pop, display, initialize, everything together makes a stack, right? So if you cannot put them together, you cannot make the, you cannot exploit the reusability to its the data structure probably. So if we can combine them together, if we have got some facilities for that, we can probably reusable the entire definition rather than just reusing the procedures or functions. So we can use only the procedures but not the data, which is also as a part of it. I mean, it's a cohesive part of it. Is that part fine?
Yes, sir.
And then another problem that we you have not felt and you have not probably you are not worried about till now, but probably if you are given a chance you could have I mean you could have thought about it. Okay, so that would be nice. One is in C when you write these procedures, so these are the procedures, and you can have some local variables declared here. So these are local variables, and you can have some global variables. Okay, so these are the two options. and there is no way you can bind these related things and all this. That's fine. So here, so this is, so this global, what is means, this global are visible to anybody, and these local are visible to nobody. Is that fine?
Yes, sir.
Yes,
Yes,
sir.
sir.
So either it is
Yes,
visible to everybody or it is visible to nobody. So it's just like you have a car. If you leave your car outside your house, that means anybody can use. It's something like that. And if you put it inside your house, that means it is your private property. So everybody knows that it's your. So you have a bicycle. So it's like in your hostel room. If you keep your bicycle within your room, then everybody knows that it is your private property. So you can, other friends cannot use it. But if you keep the bicycle outside your room, that means it's a public property. So anybody can take your bicycle and leave it anywhere. So that is probably not good. So what you expect in a realistic situation? So you have a bicycle. So what do you expect in a realistic situation?
So some can use
It
it,
should
some
be
cannot.
private, sir.
Thing is, you should be able to. So one thing is, if I keep it outside, definitely I mean that anybody can use. That's fine. So it's like a, you have got a football. So maybe anybody can use and they can play. You don't care about it. Okay. But if it is a bicycle, probably you'd like to share it with your, not to all the entire public, but you probably would like to share it with your friends only, right? But you have got your mobile phone, and that is your kind of private, because we have got many valuable passwords and all saved there. So you would like to have it as completely your private property, right? So you've got a phone that you want to make it, that you want to have it for your private use, nobody else can share. You have a bicycle that you would like to share it to your specific friends, or so you have got a certain degree of control whom you would like to share with. And you have got your maybe a football that anybody can use and play. You don't care. Okay. So are you getting the distinction between these three?
Yes, sir.
Or
Yes.
Yes,
say
sir.
maybe we can take another example, that say you so during your course of study, so you have not yet visited hostels, that we all know, but maybe you have procured some books. Okay. You have got some Xerox notes, and then you have got a laptop in your possession. So which one of this you would like to make so public means, now generally in the hierarchy, so when you are leaving in the final year, or from the fourth year, third year, or going to the final fourth year, so you will always have, some followers. I mean, some juniors will follow you, they will take advice from you, and they will always believe on you. Whatever you say, they will do that. Okay. So they will have some followers. So what you would like to share to all? I mean, anybody can use. So which
Notes.
of these
Book.
you may not care at all.
And
You may share it with anybody. Which one?
So books.
Xerox
notes
notes.
and
So this is safe, maybe public. But which one you would like to share only to your followers, or to your juniors who actually are you have good acquaintance with?
Books.
Maybe the books.
books.
So that we say some other term, we may call it something we said later. And what about this laptop? Would you like to share it with anybody else?
Private.
So this is
No,
private.
No.
sir,
So
private.
you would like to make
Private.
it private. It's completely, I mean, you do not want to share it with anybody. And this one, we may call it as protected. In C++, do you have any such provisions other than this? So if I try to draw the analogy, so which one is public? So in C you have got global and you have got local, right? So while trying to say that it is mine and it is for anybody can use, it's for public use. So is there any connection between these two, this global local and this public protected private? So
Public. So global is public, local is private, in that.
Hello?
Yes, sir. You're audible.
Yeah, I think there was some connection disruption. And the local is more like
Private.
private. Is there anything something that you can label as protected, or you can treat it as protected
No,
in
sir.
C? No.
No.
So it's not possible. So the one thing is the complete focus in C plus in C in procedure oriented programming is the complete focus is on modules and there is no emphasis on data. So you cannot really, you don't care about data, you don't have a fine tuning of whom you share and all this. So those things are not there, and that was not felt in the design itself, and also that was not felt in the entire design philosophy. They didn't bother about that. Uh, that was a I would say the first kind of design paradigm, programming paradigm. But later on, to address these limitations, the object-oriented programming paradigm was evolved, or it was, it came into existence. So got the point? Why? So complete focus on modules and no emphasis on data. It has got two implications. One thing is you cannot combine these two, the cohesion between data and modules, because you don't care about data. You say that let it be global or local, I don't care about that. So you can care it in two ways. One is the related things can be put together in a combined structure, in a enhanced concept of structure. And another thing is when you are trying to make it public or private, you can also have another kind of feature through which you can make it protected. So we'll see that how this protected uh, uh, makes sense in our object oriented design. That in details we'll see that, but I think you got the basic idea that why sometimes it may be required, right? Is that part okay?
Yes, sir.
Yes, sir.
So now can you see this? So can you see this mm, picture? So this again just gives a outline of something, some outdoor scenario. So as a programmer, if I would like to model this, whatever you see, because maybe you will be doing something out of it. So if I would like to model this, so the first question that you ask is, or rather I ask is, what do you see in this? What do I find in this? So you are a programmer, you are asked to model this. So maybe it's as you can see, so as a whole, what is this? This is maybe a the scenario that I'm trying to explain is institution in IT Durgapur, and you are trying to probably come up with a database or with a software that will have the functioning of this entire institute, right? With all its stakeholders. So when I describe this, so as a programmer, what things you can find out here? What things uh, are interesting to you that need to be modeled? Hello?
The the ATM, the SBI.
Yes, and
Can you
what
please
else?
repeat the question?
So the
Bikes
students,
are
The
there,
people,
People.
cars.
the
Students or
cars,
persons that are moving around, and what else?
Cars.
Cars, and what only cars? There are bikes
Bikes.
also. So maybe cars and
Bikes.
bikes together, or somebody say that okay, cars are not as same as bikes, so maybe, and somebody says that okay, let them be called as vehicles. And what else are there? There are trees. Sometimes we are interested in maintaining the trees also, so you should record the location and the maintenance of the tree all. And there are buildings also. There are roads also, that probably you can have some. So what type of road it is, what kind of vehicles you can are allowed, how many vehicles and all this. So there are so many information, and then within the buildings also there are, you can see the windows and doors. So you have to keep track of how many windows are there, how many of them are functioning, all this. So you say that I can see so many things. And maybe if I say that the persons, now these persons, who are the persons? Who are these persons? Are they all students?
Students, faculties.
There can be anything, student, faculty, staff, there can be outsiders also, because this SBI is there inside the campus, so outsiders also are coming to only SBI, so they are pure strangers. So when I say persons, how many persons you can figure out here? 6, right? And when I say vehicles, how many vehicles are there?
6.
6. Now when I say vehicles, maybe my perception is not to distinguish between two four-wheelers and two-wheelers. I say that all are vehicles. I really don't know that whether that might be a big problem for me later on, but right now I am happy with vehicles. And there may be something else like the persons. You can see that each of the persons, almost every day these days, everybody of us carry some smartphones, right? So see, these yellow ones may signify the smartphone, say for example, so these are smartphones. So we can say smartphones. How many smartphones are there?
3.
I guess everybody is having a smartphone. This
6.
one, 2, 3, 4, 5, 6, and this person may be having 2 or maybe 3 smartphones. Okay, so smartphones, how many are there? Total 6 plus 2, 8, right?
8.
Yes.
So in that way, and you can say that okay, there are trees also. So how many trees are there? You can count 1, 2, 3, 4, 5. So 5 trees are there. But again, you can say okay, these trees are these trees, and these trees are not the same. They are of different types. So and different kind of maintenance. But again, what I mean to say is it depends on your perception. If I would like to report the items that you find, you will be reporting in a different way, and might be that I'll be reporting in a different way. So the perception is completely different. So what I'm trying to say is when I talk about real world problems as a programmer, the first thing is what I perceive. That perception is completely different. So first of all, irrespective of, and apart from trees, we have got buildings. We have got 2 buildings, as you can see here. Like that, it goes on. Now the first thing is now whose is better or good or bad, that comes different. But the thing is, first thing is the perception is different. But what you in general, what you perceive, what any programmer perceive in a given problem, what you would like to identify, each of these unit person, each of these vehicle, what are these?
Objects.
So these are something which you can realize, which you can differentiate from the other. As you can see, from visually we can differentiate, and which we can quantify, which we can describe and all this, right? Is that fine? So what we are trying to, given this figure, what we are trying to find out, some entities which are distinguishable, which are definable, which are quantifiable, and which you can describe and all this, right? That is what you do. But based on your understanding, your experience and perception, you that differs. How many entities you identify and how many entities I identify and all this. Is that part clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now the thing is maybe that now after giving this picture in your mind, I mean explaining that as a client, then I say that okay, I am not interested with trees and these buildings and all this. I am now focused on these portions. So when you give me the report, then I say no, ignore it. I am focused on the persons, vehicles, and smartphones. I would like to have the database stored all these, and then I would like to have some say something that I need to operate on these things. So you can ignore that part. Then you said okay, I am happy. Now the next thing what you would like to do, now as a programmer you have to find out how I have identified a person. Now how I have distinguished a person from a vehicle, or a vehicle from a smartphone, right? Or I say that there are 6 persons. So what are those attributes which are common to all those 6 so these are all entities. So 6 plus 6 plus 8, so 12 plus 8, 20 entities you have after all identified, say for example. And what are the how I basically define? So I say that person, so these are all persons, I say. Now what are the things that are common to them? What are the features that are common to them? That's why you say that these are all persons, no matter what they do, how they look like and all this. So What is the next step now? How I define a person, right? How I define a vehicle, how I define a smartphone. Is that fine?
Yes, sir.
Now, if I come to that, what I can see, how can you define a person? Maybe you can say that, okay, I know that everybody will have a phone number. So that is at least these days, it may be a smartphone, it can be an ordinary phone, but everybody will have a will have a phone number, right? So, and okay, so let me come to the phone part first. Okay, so the phone. So I'm coming to this part. Sorry, let it be just phones. I'm not sure whether they are smartphones or they are normal phones. So how we define a phone? A phone will have a phone number. Definitely a phone these days, even though phones do not have SIM cards, they are used for other purposes like uh, YouTubes and all this. But again, a phone generally will have a phone number. It will have a receiver and it will have a transmitter, right? And it will have a kind of make, the OEM and all this, manufacturer and all this. So a phone can be defined through these characteristics: the number, the SIM that has been installed, the make, the receiver, the transmitter, and all this, or what kind of technology is used and all this. And what else we can define out of a phone? What a phone does. So this is not the only thing. So phone is an entity which is capable of doing something. So what is capable of doing? You can make phone calls, you can receive calls, you can make calls, you can receive call, and you can, these days you can send messages, right? uh, Send message. Maybe these are the functions that a phone can do, perform. Okay, if I come to a vehicle, what we can do? A vehicle, what are the characteristics? A vehicle will have a number, registration number plate should always have, and a vehicle must have wheels, because that is a bare minimum. So it can have 2 wheels, 3 wheels, 4 wheels, 6 wheels, whatever, but the number of wheels. Okay, and a vehicle, so this is how I can characterize a vehicle number. You can always go with the color of the vehicle, and then the make, uh, I mean, who is the manufacturer of the vehicle, and maybe the owner of the vehicle. These also you can add, right? And what else? So these are few things through which you can so you say that these are the attributes through which I can identify a specific vehicle. But apart from that, you know that all the vehicles are capable of doing what? You can drive a vehicle.
Sir,
Yes.
sir, we have a class from 11.
Okay. Okay, then let me stop it here. I'll take the class, maybe a class or maybe a lab, I don't know how I call it, from 3:13. Okay. And in the class, mostly the C++ assignments will be given a little bit later, because after at least 1 or 2 weeks. But before that, I can give assignments on hashing and graphs and all this that I left uh, that are left to be covered in the previous semester. But in this class, maybe I'll continue with a bit of the theory that I'll let you know. So we'll meet again at 3:30, 3:15 today. Okay. Any question? Anything else? Hello?
No, sir.
Okay, I'll share these slides. I'll create a group mail in the, and all the CRs I'll share the slides, and we'll again have topically we'll divide the topics. 3 of us will be taking this course: myself and Abhijit Sharma and Deepanita Das. Okay. So you got nothing to discuss. So I am leaving and we'll meet on 3:30. Okay. Bye.
Thank you, sir.